Okay, let's get started. Welcome. Friday again. I always get the Friday slots. I know you all want to go home. I want to. So let's talk about Python. Python's a big topic. Wait, how many lectures do we have on Python? Lots. Lots. Five? There are two plain ones? Okay, well, maybe we should look at the schedule because I'm prepared for one.
There's Python part 1 and Python part 2.
Those are videos for it, but is there?
And then
oh crap, that one. Oh, it's offline. Okay, good. Python packages and then NumPy. It does okay. Anyone watch the video for today? Oh, a lot of you did. Yeah, actually. Okay, cool. Well, then some of this might be a review, but we'll do something maybe fun at the end. Maybe not. Depends on how it works out. But I want to get a feel for all of you. How do you feel about Python? So I guess how many of you like Python? Yeah. How many of you don't like Python? I want to stand out and be. How many don't care at all? It's a language. How can you like it or not like it? I get that. Yeah. Well, I am one of those that I love Python. I remember learning it very distinctly. It was for a class. And it wasn't like, oh, let's teach you how to use Python. It's like, no, you need to use Python in this class. Good luck. Oh, I was really mad at the professor, actually. Python's not that hard to learn, but it was annoying. I remember being very annoyed with white space being important. Like, what are you doing? Like, that's the stupidest thing I've ever heard of. Like, curly braces are for life and everything. But I have converted over to Python. I love Python. So I do believe it's the right tool for the right job. It just happens that Python's the right tool for almost every job. Not really. But so to take a step back, to try to illustrate my love of Python for you, I have a couple of children. I have 4 kids. And one of the great things about having kids, you get to read books to them, right? At bedtime. And so I have my favorite, books, picture books from when I was a kid. But then there's new books that come out. And so one of these new books that's come out, which is a great one, you should get it from the library if you can, is Secret Pizza Party. It's hilarious. Anyone read this book? Starters, you read it? No? Not with you? Okay. I don't know. I mean, there's so many books nowadays, there's a lot, whether you get it or not. Okay, but one of the pages, it's a joke about getting a raccoon to get some pizza. But it's a poem of love to pizza. One of the pages is this. Pizza. Pizza. So beautiful, you could hang it on the wall of the museum. So convenient, you could eat in a bathtub. They love pizza. So I feel the same thing about Python. I think Python is beautiful in some ways and so convenient. You can program it in the bathtub. I love Python. I think it's used for a lot of different things. And so I thought of this book when I was thinking about, how do I love pizza? Or I love pizza also, but in Python. So that's where I'm at. So, and you can try to crush my spirit and tell me, well, the reasons why Python's not great, but I won't listen to you. But I will say Python is not perfect. There's problems with it, right? There are issues, and I'm well aware of those issues, but nothing's perfect, right? And I think it's a pretty good language. I think there could be a better language out there. I think once again, the right tool for the right job. You all know the saying, right? When you have a hammer, everything looks like a nail, right? You've heard that, like same kind of things. Like if you love Python, like everything's gonna look like, oh, Python can solve this problem. I believe in the opposite. I feel like you should be thoughtful about, okay, is this a C type job, a C++, Java, Python? But it just so happens for research, at least the research I do, Python fits really well a lot of times. You need some quick scripts to process some data or analyze something. Python often is the right job, but it's not always the right job for like an embedded system or other types of tools, or you're gonna be processing lots and lots of data. So it's not always the right tool, but it's a great thing to know about and a multi-purpose tool. So in the heart of this, this page right here from this book, I was thinking, what do I love about Python? And so I'll go over, I guess, 3 or 4 kind of things I love about Python. And then I thought it'd be cool to kind of just write a program together. Because I feel like there's things I won't talk about in this, but maybe will come up as we write this program together. So that's what I thought we could do for a little bit. So first, let's talk about kind of general Python stuff, and then let's actually write a program. That is semi-complex, not really that complex, but okay. Let's bring up Python here. Is that big enough, everyone? Can you see that okay? So one of the great things about Python is that it's quick and easy to write, in my opinion. There you go. Type in Python, all of a sudden you're ready to type in code. Awesome, 1 + 1 is 2. Try doing that in Java, right? You have to write a class, and you have to write a function, and you like, my hello world program is 1 line. That's pretty awesome, in my opinion. So if you got to write something quick, Python could be a great tool for that. You can do lots of interesting things with Python. Python has your typical types, strings. It can be with single quotes or with double quotes. Actually, doesn't matter. There's no chars in this case, so a single quote is a string still. Numbers, as you'd expect. You can have really large numbers if you want. Python kind of abstracts that away and you don't have to worry about what can fit in what type. And into the 100. You can do, one of my newest kind of things in Python I like is you can do separators between digits. They mean nothing to the actual program, but it's good for human readable purposes. You can have underscores in your numbers, so it kind of helps separate large numbers. Lists are important in Python. That's how you make a list. You can mix and match types. I love that about Python. I have a number, a string, and a Boolean, a true value or false value, all together in one string. You don't have to, or all in one list. You don't have to have a list of just strings or just ints, which is really nice. You can index really well. So let's do list is equal to, let's do another list. Some good indexing capabilities. So list, you index it like this, square brackets, that's your first element, your 0th element. So third element, etc. You can do -1. Anyone know what -1 does? I love that. That's a great feature. I don't know why every program doesn't have that. That's so nice. You can slice and dice this thing. You can say, well, give me the first from the first element or the second element on. Third, you can break this up if you want to. There's all sorts of crazy things you can do with lists and slicing it and indexing into it. Like that. Great stuff. And sorry, I thought I was in my terminal. I'm not by any means this is not meant to be like a tutorial. Go watch a YouTube video online, which is much more professional and better and more exhaustive. Just a flavor for kind of things you can do that I like and make it easy to use tuples or tuples, depending on who you ask, or denoted with braces, brackets, I guess. What's the difference between a tuple and a list? Change tuples. So pretty much they're very similar in lots of ways. I can index into them the same way, right? But you can't set it. So I can't do this. It doesn't let you do that. With my previous list, it could have done that. So it's kind of like a read-only list. Dictionaries, that's also a big thing in Python. Dictionaries, that's with curly braces. You've got key values. You can match your types there as well if you really want to confuse someone. And then I should set that same. T is equal to that. So now I can get that item, test that, or I can get that. Dictionaries are great. Hash maps, whatever you want to call it. And there's so many more cool things you can do. I wish I could show you all of it, but I'm just trying to give you a feel. Last kind of primitive data type would be sets. 1, 2, 1, 1, like that. So it takes all that, and so a set is can only have one thing in it of the same type or same number value. Any questions on that? Anything anyone wants to see? I'm sure you've probably done this before, or maybe no.
With that set, right, you made like a list within it. If you had like another list, would that be how you build a matrix?
Matrix, that'd be like a 2-dimensional array, right? Yeah. So list inside a list. Yeah. So you can do like a.
Oh, okay.
It's like that.
You wouldn't use set to do it.
Wouldn't use that. Okay. That would be a 2-dimensional array. Yeah, I'm trying to think what else. Oh, one thing I guess I didn't say, I'm in the REPL right now. What does REPL stand for? Read, evaluate, process. 5? So look it up, I don't know. REPL. So that's programming languages sometimes have these. Does C have one of these? I'm sure you could make one, kind of pretend like it was there, but no, you wouldn't want to do that. Why does Python have a REPL? I can type in things and prints it out for me right here, and it executes it instantly. In C or C++ typically don't have that.
Python is cool.
Yes, exactly. Yeah, there. Very good. Yeah. So it's doing it on the fly. So it can take a string and evaluate and output it results. Whereas these other languages are compiled. They need to go through a compiling process first and then output. You could, in a compiled language, do this kind of thing and just be, more trickery behind the scenes. So this is nice. I don't tend to live in the REPL. I use it if I'm like quickly like, wait, why was that a syntax error? Let me experiment with some kind of weird Python thing that I'm trying to understand. So if I need to do it, but usually I write everything in a file. It gets pretty cumbersome quick, for I in range of, like I always get thrown off by like, you have to indent and it's like, well, I indented too much. Okay, like, I don't know, it's confusing. Do I have to indent again? Okay, yeah. Anyway, so you can do lots of things in there. I don't love it, but it's nice for kind of quick debugging or just demonstration purposes. Any questions on that? Okay. So let's go to a file. That's where I feel more comfortable.
I have a question.
Oh, yes, please.
When you launched your REPL, you typed Python 3.
Oh, thank you. Yeah.
Why'd you type Python 3?
Because that's the only version of Python you should be using. It's Python 3. Do not use Python 2. It's dead to me. It's dead to everyone. It's deprecated. Don't use it. Did that answer your question? I mean, now Mac actually doesn't come with Python 2 at all. If I type this in, it says, I don't know what Python is. You have to type Python. You'll see later on right here, I actually have Python 2 alias in my environment to Python 3. You can see right there, it is running Python 3, 3.9.12. But just know, yeah, don't use Python. That's, I was going to talk about that later on, but yeah, don't use Python 2. I mean, sometimes you have to, I guess, if you're running a legacy project and all the libraries are in Python 2, sometimes you need to. But if you're going to start a new project, use Python 3. It's so much better, and that's the future.
If you're using a library from Python 2, you have to ask, is anybody else using this library?
Yes, this is worth it. So I thought it'd be fun to have kind of some more, kind of more type fun. Like, so here we got a number. So it's like one interesting thing is, let me run this real quick, okay? Is that like, so far we haven't talked about types, right? I set all these variables, I didn't tell it what type it was. See, you guys say, oh, it's an integer num. Here I just say, oh, num is equal to 5. Add them together, I said, but there is a type right here. I do what's the type of num? It gives me int. So what does that mean? So Python has a certain characteristic to it that some other programming languages have as well. It's called dynamic typing. So it's dynamic, so it still has types. It's not typeless. It still has types, but it's dynamic. It can kind of figure out on the fly what your types are, which lets you do cool things, but also doesn't let you do anything. So here I have two numbers, as you'd expect. I can add them together. Let's take this text right here. I have some text. In the text, can I add the text? Interesting. Like, why would I want to add text together? Does that make sense? Run it. No. Save it first and then run it. It works. Concatenates them together. Okay, that makes sense, I guess. If you want to concatenate two strings together, add them together. Okay, makes sense. And sure enough, it's the type string. Can I do that with a number and a text? No. Your JavaScript, who knows? In Python, you cannot do that. So they decide, no, you can't do that. You could, of course, you say, well, I really want to do this. So hey, take this number, cast it as a string. Say, no, this number needs to be a string, and then add it. And then you get your desired result. But to take a number, slide, you can't just add a number in text. Okay, sure, that makes sense, I guess. Look at lists. That list, can we add two lists together? What do you think? Who do you want to take bets? Can you add two lists together? What would that do, you think? Would that be a type error or what? Both lists. What should it do then? What would a sane person think it should do?
Very long list.
Very long list, okay. Yeah, put the two lists together, okay, that makes sense. Actually, in Python, strings and lists are like, siblings. They're really similar to each other. If I pull up my REPL again here, if I have like a test is equal to test, I can do test, I can get the zeroth. It's essentially a list of characters, my string. And so they're very similar properties. You think of two lists concatenating together, two strings, well, they're both lists, they can concatenate together. Okay. What happens if we add a number to a list? I expect it doesn't work, darn it. But you can multiply a list by number. So, and it just repeats that thing that X amount of times. So there's all sorts of things, you just gotta kind of learn it. Some of them are intuitive, some of them make sense, but some of them are also just things you learn as you go along. Here, an example of, let me come out the rest of this up here. Where you know, just because a variable was set to a certain type doesn't mean you have to keep that type. So here it's a string, then it becomes an integer, and it becomes a number or a list. And Python's totally happy with that. Whether that's good practice or not, I'll leave that up to you. I like to do that. I think it's nice, but you know, maybe some of you would cringe at that and not want to do that. I think here, different ways of writing integers. Oh, one nice thing in Python also is equals does a string compare. Doesn't, you know, like you would expect to, not like what Java does or where it does, you know, based on the object. So if I do that, it will check to see if those are the same, you know, strings line by line or character by character. And the last thing I wanted to point out for this part of it is that there are, I already showed you one, there are certain values that represent truth, true or false. It still annoys me, they're capital. Get over it, I guess, but that's how Python does it. They're capital T and capital F. I wish they were lowercase, but those are true and false primitive values. Any questions on the types? I don't want to see anything crazy. No? All bored? You've seen this all before? Or is it this Friday? Yeah, I'll just assume it's Friday. Let's see here, anything else? So I mean, so this, my point, I guess, so why I'm showing you this is because I love it. I think it's quick and easy. It's not the most disciplined way of writing code, being able to change your types and multiply things together. But for a quick script that you want to write to get something done, it's great. So it makes it quick, easy. I'm like, I don't have to worry about types. I just set this to integer, and then later on I can set it to something else if it makes sense to set something else. And so all this makes it really quick to program, prototype, and to run something, you know, and process data. But there are drawbacks to this, right? It can be hard to follow. If you get a parameter, you know, value in, you don't know what that value could be. Is it a string? Is it an integer? You have to kind of trust the person that's calling your code. Whereas in, you know, something like C or Java, it's guaranteed to be that type typically, and so you know how to handle that data. So there can be problems with the dynamic typing, kind of loosey-goosey technique. But overall, I think it's great for kind of quick stuff. I love that Python is flexible as well. In the website, they call it multi-paradigm. So essentially, you can do whatever you want. So multi-paradigm means there's different ways of writing programs. You can write in kind of an object-oriented type of way. You can write it in a functional kind of way. You can write it in, I think there's data logging. I don't know. There's lots of different words for these. I don't know all of them. But I love that. It's like you can choose what's best for you or let it grow with you. Maybe you start with a quick script and say, okay, I want to write this script here and just get it done. And you realize, well, actually, I should probably make these into functions. And you write, actually, this should be a class. You can slowly add to it. Whereas something like Java, you're forced to use classes right away. And that's kind of how everything's done. So here's an example of that. Here it says, I'm a script. And we got a demo function we call right here that says, I'm a function. And then we create a class right here that says, I'm a class. We can run all that. I don't suggest you necessarily mix and match all these things in one file necessarily. I've done that though, and there would be reasons maybe to do it. Maybe probably lots of reasons not to do it. But I like that. You know, it's not telling me how to write my program. It lets me grow with my program and decide how I want to do it based on the problem at hand. I'm not saying you have to use classes, you have to use objects, figure out how to make your problem fit into that. It's like, no, if I just want to write some quick things, I can just do that. If I want to write a couple of functions, I can do that. So I really like that you can match these things together. Any questions on this? Yeah.
Maybe you're going to get to this later, but
why not?
Classes, and their parameters, they have self.
Yes, actually, I was going to get to that. I'm glad. So I was going to ask, is there anything strange about this? So I'm glad you noticed there's some strange things about this. There's two things that kind of stand out to me as kind of strange, and you noticed one of them, self. The other one is the word pass. I don't think there's an equivalent in any other language. One thing I should quickly say while I forget, don't forget is there's none is another keyword in Python. That's equivalent to our null, which does not exist in Python, but like in other languages, that's null is our none. So just know that. But pass is kind of interesting. I don't even guess what pass does before we get to the self. It does nothing, yeah. And I think if I understand, I think you can put pass anywhere you want, really. It doesn't make sense to put it anywhere else. So why would you want a line that does nothing? Like, why not just put nothing? Like, why do you need a line that tells you it does nothing?
Something that's supposed to do something, but nothing.
Yes.
Put some curly
white space, yeah. Yeah, and, C is just done. You put your curly braces, you're good to go. But yeah, here it's white space sensitive. It's going to say, okay, let me get to the next line. Okay, so well, that's a blank line, so I'm going to ignore that. Ignore blank lines. In Python, you can do this. That's still the same. So it's going to get to this line. Say, well, wait, like it's going to get very confused. It's not indented right. You're doing a definition. All right, it's warning me. There's a syntax error here. You need to have something. There needs to be code inside this init. It can't just jump to the next thing. And so because Python is white space sensitive, you have to say, even if it does nothing, you have to tell it does nothing.
Is that kind of like equivalent in C? There's the continue, like you use in like a loop. It says like, if else, just keep going.
Yeah, I mean, I see what you mean, but no, there's a continue in Python as well. And those are different. Continues can only be used in loops in C and in Python. And yeah, tell it go back up to the top of the function. Here's more of just like it's a no-op. It's like I need to fill a line, but I don't want that line to do anything. I mean, I guess you could have
it's the same as two braces.
Yeah, I mean, so you can. I guess you could put something there. You could probably put a valid piece of Python in there, and probably executing. But why would you do that? You're trying to convey meaning. And so yeah, it's the same as as putting.
It's actually kind of the same in C, right? You do an if statement. You don't need braces, but you can't just put an if statement with nothing underneath it. If you don't want anything in your if statement, you do have to put some braces. So it's similar to
it's like just an empty return on a void function.
Yes. Yeah, you could put a return.
But it doesn't return. You could put code after it.
Yeah, but it wouldn't execute that code, right?
Mm-hmm.
You think it would?
Let's figure it out. Doesn't it? I don't think pass does anything. It just doesn't know op, isn't it?
Yeah, you're right. Yeah. It still executes it.
Sometimes I just put them in every year. No.
Every line is a pass. Really makes someone bad. Yeah, be careful when you pass. Like don't only use it. So I mean, there's it works in code, but then there's the human side of it, which matters probably more. Like you're gonna upset some people if you start putting passes random places. So convey the right meaning for what you're trying to do.
Not on a code review. Not enough passes.
Okay, so everyone understand the pass? Maybe not. I don't know. I would confuse you all. Self. Let's get to self. What is this weird self doing right here? Anyone have any thoughts?
It's like this.
Yeah, it's like this. Now you're talking about yes, it's like this. Yeah, it's well put. It's how do you reference yourself? If you're in a function, how do you reference your own data types? And here we don't really have any data types. I didn't make that complex, but if I did self dot data is equal to 1. If I'm over here, in this function, how do I get this piece of data? I need some way of saying this thing or self. And so Python, the convention is to do self dot and then data. You can print that out. Make sure, let me add another pass here just in case. So you could do that. So self is a way to denote it's who it is. I will tell you, hopefully it doesn't bug you, but self is actually nothing special. It's not a key word in Python. It can be whatever you want. It's convention to put self, and you should put self, but you could put test. You could put test, and you could refer to it as test. It's just whenever the first thing in a method is always itself. It's a reference to itself, and so everyone just calls it the self. But you don't have to call it. So there's nothing special about that word. It's just when you call this run, what's happening behind the scenes is actually calling a function and it's passing in this, or the class object. So, but follow conventions. So use self. and then just know that's how you use it. So if you want to get data from shared data between different functions, that's how you do it.
And also don't forget to put self, otherwise it won't run.
Yep.
Because it will try and pass the argument in and it'll be like, oh, this function doesn't take any arguments.
Let's run that. So let's forget to put self in there. That's not the most intuitive error. If you don't really understand what's going on, you're like, wait, like why? Like run takes 0 positional arguments, but one was given. Who gave run one argument? I didn't give run an argument. Python did. It tricked you. It's a switcheroo. It's like saying, no, I'm actually not going to call this. I'm going to call this instead, and you're just going to, know that behind it. So if I call run with like a parameter, this is what they'd be calling really behind the hood. It would take 2 parameters, even though only one is actually being used, or you're passing in one. There's an implicit thing being passed in. Great job, yeah. So those are the 2 kind of weird things with Python. It's not a big deal. Once you get used to it, it's no problem. But just what is this weird self thing all about? So every method of a class should have that self keyword. It has to have it. That's it. Anyways, okay. Any other questions on that? Let's see.
What's this weird init thing?
Oh, good job. Yeah, thank you. I did not think to talk about that. That's your initializer. So that's a special. So when you create this class, this demo class, it's going to run that code for you. Now, this is a common paradigm in Python. They call it, it's a double underscore. They call it dunder. And those are special names or methods that you should never do anything with yourself, really. And so, but you do have to have this. So it's saying, when I create this class, what code do you want me to execute when I create this? And so that's your init. You need to define that, and it'll run that. So if I would print. So if I just did this, hopefully that works. I created. So I didn't call anything on the thing yet. I just created it, but it ran this code for me right here.
What do you mean that you never do anything with it yourself?
Oh, like you would never want to call demo class dot init, just like that. Like you should let, mostly if it's a dunder, you should leave it alone. You should not kind of be messing with the internals. You could, I guess, in theory, and if you know what you're doing, then sure you can, but you typically want to stay away from those. It means that there are system level, like Python level variables or names. And so you should be like overriding those. That is one case where I guess you do override it, but you should usually not be messing with those.
The idea is things that you would overwrite like less than. You could.
Yeah, there are cases where you do it, but you typically don't want to unless you know what you're doing. Like you would never want to name like, oh, I want to call my thing called run underscore just because I think that looks cool. Like, no, you don't do that. Like that's not for you to mess with. Any other question? Yeah.
Are there other conventions like, I mean, I think I've seen just
what at the beginning? Yeah. So yeah, so you can have an underscore at the beginning to denote it's private, that function. That's only meant to be used for internal use. And it won't show up. I mean, you can always call it. You can still call it and have it. It's more conventions. So that's actually goes at some of the heart of how Python was created. It's like we assume we're all trying to do what's best. None of us are malicious. So there's just more conventions and not being forced. So there's no idea of like a private class versus protected versus public. It's just kind of conventions. And so that's one of the conventions is an underscore means it's private, but you can still call it if you want. But I just trust you as the caller to do the right thing because I know you're a good person. That's kind of how Python was designed, is just to trust each other, not like enforce certain behavior. Is there, I know there's
double underscore does hide it.
Does actually hide it.
It doesn't do a good job hiding it like C or Java does. It's not really secret, but it does change the name so you couldn't accidentally call it. It mangles the name a little bit, but it doesn't really offer you any secrecy.
I think even with the single underscore in a package, that won't be imported.
Yeah, I think so. Yeah, if you do like a import star.
Oh, not import, but you could still call it with that name.
Yeah, there's certain conventions like that. Many other ones. One other convention that always tripped me up when I first saw Python, this is saying maybe you'll see at the bottom of a file, it might see something like this. And it's so weird to me that I think it's worth talking about. pass or
I don't know if I've ever seen that
what?
with just the
Pass,
pass there.
So this line is so confusing. It was really confusing to me when I first saw it. It's like, what is this trying to achieve? There's so many underscores here. What's going on? So first of all, going back to this, there are some variables that were defined for you without you knowing it. Underscore, name, under name being one of them. Let's print that out. I'm just going to exit right here so nothing bad happens. If I print that, it's going to print out the name of my file-ish. Name of the module, I don't know what, not the file itself. So every file is defined as underscore name. But so what this is doing is saying if the name is equal to main, which it was in this case, then run this code. So this is checking to see if you're the main thing that's being run, if you're the thing that the person typed into here, then run this code. Otherwise, if you're being imported, let's say, then don't run this code. So it's a way to kind of change the behavior based on if you're being the caller or if you're just being imported as a library. Yes?
So if we were to call main from a different file, it would not run the code inside that block right there.
Exactly, yeah. So let's do it import.py. If I do import flexible, okay, so then this is print test. So this should do nothing. I'll show you an example where it does something just to illustrate. Like it does do something. I have the script. Let's get rid of that. Okay, so it prints test, but let's like remove these lines. Let's remove that if, let's make sure now it's going to run that code. So that makes sense. So sometimes like you're creating a library maybe, or you're creating a function, but when it's called on its own, then do this stuff. But if it's being imported, then don't do those things. So maybe I do want to do like flexible dot whatever demo function. So I can still use it, however I want to use it. But you maybe don't want to have certain behavior. I'm trying to think of a good example of why you would want to do this. I've seen it sometimes as like, hey, if you want to use this file by itself, the main is kind of like an example of how to use it, but if you want to import it, if you just want to use it functionality up here, then don't bother executing this code.
Sometimes, I mean, it's powerful in that like sometimes I make a class or something and then I want a little bit of test code to validate it and try it out. It's like, oh, I don't want to make a whole nother file. So I put a little test code at the bottom. But I don't want that test code to be run every time I import the file from somewhere else. And so you kind of put it in this main thing. It's, I don't know, when my brain sees it, I think of like, oh, I'm calling this is main, like writing C code, like this is my main. And if it's from somewhere else, it's not going to run my main. But when I run this directly, the first thing it does is run my main kind of thing. So
well put.
And I often then make a function called main and run it from there.
Yeah, that's a common convention. I do that.
Yes, I was raised as a C programmer. I don't know. This is often what I do.
Like that, and then maybe put your code in here instead. So, yeah, I do that often. That's a common paradigm. I don't know. It depends on kind of what you're going for. Okay. So it's flexible. I feel like there's a lot of cool things you can do with Python. Another reason why I love Python, I'll just briefly touch on this for maybe those that are interested. Python's really deep. There's a lot of cool stuff to it. At the end of the day, Python is actually just like a bunch of dictionaries and you can kind of hack away at it and change its behavior. And there's runtime stuff you can do. There's like meta classes. There's a lot of cool depth to it. If you're interested, go look at some PyCon videos. And there's like, it blew my mind, just all the cool things you can do with redefining behavior. You can override variables. You can override operators. There's a lot of cool things you can do in Python because it's kind of built on a simple system of dictionaries. And so you can, usually you don't want to do that in real life because that's going to make people mad and change behaviors. But I love the idea of it being deep and you can kind of get it to do what you want it to do, even if you shouldn't be doing that. So it's
maybe on that note, can you print dir of demo class just so that people can see all the stuff that.
I guess I should do it here, right?
Yeah, I guess so.
So dir is another thing that's defined for us. I don't know what that stands for actually, but it tells you kind of all the methods that you can call on this class. So all the magic, I only defined two functions, right? Init and run, but actually there's a lot more to it than that. There's delete attribute, there's a dict, there's a dir, there's a doc for docstring, there's the equal to, a format. I mean, there's so many things here that you could, if you wanted to, reach in and pull it out and change its behavior. I mean, really don't do that. But you know, there's a lot of cool things you can do with this to change its behavior. I mean, just as an example, I mean, there's the call. Okay.
Yeah, I mean, it could overwrite string for an example.
Yeah, well, there's a really, yeah, it's fine. Anyways, well, there's lots of cool deep things you can do.
Yeah.
I'm not prepared for that, so I was embarrassed myself. So I won't do it. But if you're interested, come talk to me afterwards. You can like override so that you can essentially arbitrarily call anything class dot anything you want here, and you can essentially handle that in your code to handle this thing, you know, whatever the person typed in code. It's really cool.
You can like catch all.
Yeah, like there's a special, you know, how you can override, you know, less than. There's a call or something like that, like where if anyone calls you ever and it doesn't know how to handle it, then it'll just go to this and you can, and you know, handle it here, so like a catch-all.
You should print locals.
Print locals on the class. You're saying the double underscore, is that, or is it just dot locals?
Just underscore locals, I think. I don't think it's on the class. I think it's like a global variable.
Oh, like this? I know there, I know
I've done that before where you.
I know there is something like that, but I don't know off the top of my head. That look it up.
It be locals with no underscore.
Okay. It's a keyword. Built-in class. Yeah.
On function.
Other function, I mean, yeah. There's a dictionary of class, yeah.
Oh, it's all your local variables.
Variables, so like,
I see. So you have a variable called CLS, and its type is, or its value is this.
so like lots of introspection. You can like get access to your locals, add new locals in your code. I mean, you wouldn't want to do all these things, but sometimes you do. And it's kind of fun to know you can if you want to. Anyways, we're doing time. Okay, I want to get to the fun part. So I'll say one more thing that I love about Python is its library support. There's so many libraries. I've learned now in Python to never write Python code without first looking online to see if someone else has written it for me. I just feel like, I think I'm so clever. I'm like, oh, I'm gonna write this cool thing. And then I look online later, I'm like, oh, there's like 5 versions of this. Why did I spend all the time writing it? The big popular ones that we will have a whole lecture on is, you know, pandas. This is great for like data analysis. NumPy is also a great one for dealing with arrays, and there's so many cool things to this, like there's a whole lecture dedicated to it. So just, there's some great library support for, you know, fast math operations, optimizations, machine learning, things like that. So that makes Python really powerful, not because the language itself is powerful, but all the contributions from other people that have made it powerful. And so it's a great place for machine learning, for data analytics, for also multi-processing type of things. Okay. Python gotchas. Only use Python 3. It's white space dependent. We'll show in a second. There's these weird keywords that kind of seem out plays a little bit, and or not. Those are literally the words. So if you want to say like this has to be true and this has to be true, then use the word and, not the, you know, ampersand, ampersand. Same thing with or, not. So they're spelled out in English, not a symbol like they are in C. True or false, yeah. Anyways, any other questions about Python before we build something together? I'm nervous to build it because I want to build it from scratch. I did test it out, so I kind of have a template, but I want to do this together with you. But any questions before we start that process? Okay, let's build this pretty quick. We got like 20 minutes left. I love interacting with the web. I think it's so fun to take a program that's running on a computer and do things outside of the computer. I just love that feeling. And so one of the things I love to do is scrape websites. It's both invigorating, get in trouble potentially if you do it wrong, but also it's useful because there's some value to it. So for example, just make it concrete. My wife really wanted a certain IKEA couch, and it was out of stock, and it was out of stock for a long time. And she said, write a script to figure out when it's going to be in stock so it can email us. I'd offered this service once before. So I can do that. You know, like I've with computers, I can do this. She's like, okay, fine, put your money where your mouth is. I can do it. And so I did it. And it wasn't.
I often want to do that, and I think if I was Dr. Lundgren, I'd know how to do this.
It was, of course, not as easy as you think. Like, oh yeah, just take like 5 minutes. No, 5 hours later, you're like, oh, okay, fine. But I did get it working. But how IKEA has set up its API, which is not public, I had to reverse engineer it, which is wrong with issues as well because they can change anytime they want. But one of the cool things is not only can you see what the stock is in Draper, you can see what the stock is across the whole country. So I'm like, might as well see what the stock is across the whole country. And so for a month I was tracking, like there was some in stock in California, like why aren't they in Draper yet? Like, it's like I kind of see, because the worst feeling is this like constantly out of stock, like, I don't know, is this product like being discontinued? Like what's going on? But I could see it's coming in stock other places throughout the country, mostly on the West Coast, really enough, not very much on the East Coast with the couch, regional or what. It's okay. Well, the nearest one is Colorado. So should we drive to Colorado to get it, or like our Vegas? It was in stock. Okay, quick. And I learned like what high stock means for this couch. High stock means 3 of the couch. Weirdly enough, I would think IKEA would have. So then low stock was 1 couch left, and you learn all these things anyway. So we're able to get the couch. Yeah, thanks.
You get to drive?
No, Draper. Came in district at Draper. So that afternoon, when I read the script, I left and go get it. So that's what kind of fun things I like to do. We don't have time to do that now. Sorry, but I did think we should make a web crawler. You know what a web crawler is? Is that like a common term, or is that like an old term that no one knows now?
Doesn't it scrape it goes across websites and gets data from them?
Yeah. So think Google or does this, yeah.
I just want to ask, like, what you were talking about earlier with like the and stuff. Is there like a place where I want to learn more about those kinds of programs where we can go?
Yeah, talk to me. There's a web scraping tutorials and stuff like that. There's a little bit of art to it because you have to reverse engineer what the website. But
I think this is how Facebook started.
Yeah, crawl the website.
Mark just crawled a bunch of profiles and scraped all the data and built Facebook.
Yeah, exactly. So yeah, Facebook was great that way. That's what Google does, right? They go off into the internet and figure out what's on this page. What are all the keywords here? So when someone searches CPE bootcamp, it'll bring up the right page for them. And they have lots of magic sauce to that. But one component of this is building a web scraper, a web crawler that will go say, here's a website. Where are the links for this website? They'll go through and get all the links and then go to those websites and go to those websites and go for all, of course, the internet. So let's do that on this website right here. Let's scrape it. And I'm getting nervous. Okay, import. So my first tool is a third-party library called Request. This makes it really easy to do HP GET requests. So let's try that out. So my URL is here. Okay, let's just like test it out. Request.get, print this, see what happens. So it's going to just, I spelled that wrong. It's going to just get that URL and give us the result back. Okay, response 200, not very helpful. Luckily, I've used requests enough to know what's going on here. Let me make this a variable response. It's saying that it got a response back and it was a code 200, which means success in HTTP parlance. Response.content is what we really want. Okay, there we are. This is the beautiful HTML that makes this page. You know, the web browser takes that HTML and does nice things with it, makes it look good. But what's happening under the hood in terms of the networking perspective is it just gives you back this ASCII text of HTML and JavaScript. It's the web browser's job to make it look pretty, but we're not a web browser. We're not making it look pretty. So we're just going to do this. That's all the stuff that's in here. It's kind of cool. Okay. So what we want to do is we want to visit a website, find all the links in that website, and then go visit those. So this probably should be like a list maybe instead of like a one URL. Let's make it a list because we want to maybe iterate through those. Okay, in which case, maybe we call this like URLs, plural. And so you say like for URL in URLs. So this is, we're seeing a little bit of magic of Python, which I love, is kind of in another language might be like a for each. Instead of saying like, well, let me do an int I is equal to 0 and get the I, like let's just iterate through those things. So here is a list. It's just going to peel off that first item on the list and set it equal to URL. I can process that URL and then go to the next thing. Now, another important thing in all programming, in my opinion, is testing often. Like I would not write more than like 3 lines of code before I test it, just make sure it's doing what I think it do, because you'll get yourself into paint yourself into a corner where you write 100 lines of code and say, wait, does this work? And then you'll hit run and nope, of course it doesn't work. In fact, I have a meme about that. I show my students. Of course, and then you have all of a sudden 100 lines to debug. And so run as little as possible. I mean, sometimes it's hard, like on FPGA, maybe that takes an hour to compile. So maybe you can't do that, but but try to run as fast as often as possible.
I might just be a little silly, but my requests, like import requests, isn't working. Import requests could not be resolved from source.
Sorry, say it again?
It says import requests cannot be resolved from source.
Okay, Paladin. So what's going on is, sorry, I did some magic behind the scenes. I did pip install request. It's a third-party library. I know, I'm sorry. I have to make it look really smooth and I guess it's very effortless. Pip install requests. And it's already cached because I already installed.
You might have to do pip3.
Fair enough.
Python 3.
If you're not using a virtual environment, I'm using a virtual environment, which is a whole other topic.
Yeah.
Okay. You'll learn about that later on. Kind of silos your Python and all your libraries into a separate folder, this VM. Okay, so let's try running this, because I mean, I think it should work. I don't know why it wouldn't work, but I've messed up on easier things than this, so Okay, cool. It's still printing out the HTML, what I wanted it to. I mean, we only have one URL, so that makes sense. Okay. So now that we have this HTML, we need to get the links. This is hard. So anyone know HTML well enough? What is a link in HTML? That's fine if you don't, because I don't know why you'd ever learn HTML up to this point, but not in our program at least, but maybe on your own. Yeah, bracket A. So it's an anchor tag. So it looks like this. A, href, f equals, and then this is the part we want right here. And then there'll be the text of the link, click here, kind of thing, and then it closes this. So that's what a link looks like. And there's also can be buttons, I guess. I'm simplifying here, but that's what a link looks like in a website. So we want this part. We don't care what the click here is. So that doesn't matter to us. We just want to know, what does this thing go to? So there's lots of, anyone have any thoughts on how we could do this? There's lots of answers, but there's only one right answer. That's the right answer. Who said that? Good job. Buy the library for it. You might say, well, let's see. Well, this is just a string, and so let's find like the A tag for it. So let's do HTML equals that. So we got HTML now. Great. Let's do HTML.find. Let's find like a href, something like let's find that. And that's probably a link then. Let's print that out. See what that happens here. Okay. Well, that's interesting. Should be an integer or byte-like object, not string. What's going on here? So I passed a string, and this thing that's important to learn in Python 3 is there's 2 types of strings. There's a string, and then there's a byte string. I said this is a string, but it just so happens if you had paid attention, it was so long you wouldn't have seen it unless you ran into this error. Come on. Seriously this long? Okay. Let me just do this. Print HTML. Let's just print the last 50 or first 50 characters. Okay. It doesn't matter, it's much longer. But see this B, this little tricky B right here? That's like, hey, this is a byte string. And so it can represent Unicode, and it's not been encoded yet or decoded. We can't get into the details of that. Just doing decode.
Strings aren't as simple as they used to be.
Yeah, they're not as simple as they used to be. So if I do this,
it's basically to support lots of different languages and things like that. So strings are more.
Yes. But that will be a gotcha at some point. So I'm decoding it, saying make it UTF-8 because it could be some other type of encoding. UTF-8 is the common one. That's actually the default. I could specify in here UTF-8, but that's the standard is. Okay, so now once I do that, notice how there's no B in front of it anymore. It's a full-fledged string. Okay, great. So we'll decode it, and then this should then hopefully work. Okay, cool. So found the index of that string, that substring. So let's do like index, and then let's do like print HTML. Let's go to the index. And let's print out like 10 characters after that. So index plus. So what I'm doing here is I'm saying, here's this big glob of stuff, but only give me the stuff from index, which is 1300, to that thing plus 10. And so that's another thing you can learn is you can, in your slicing operators, you can do math in that. So it's going to give me 10 characters from that from 1,391 to 10. So that's a little maybe too small. Let's do like Okay, so we're starting to see. Come on, let's keep going. Let's do 50. Okay, so we see stuff here. We say, okay, there's the anchor tag. Here's the href, and then there's going to be stuff. So that means this is some kind of image that's clickable. Great, but like, how do we get this part of it? How do we know like 50 is hard code? We don't want to hard code values. What if the link, this href, was like longer than 50? Then we'd be in trouble. So I start feeling a lot of pain and discomfort in this. Like, this seems like this is not the right approach. And then you jump to maybe something like regular expressions, which if you've ever used, I'm sorry for you, and that's usually the wrong answer. So, oh, I use the regular expressions. And
that's what I would have done, and I would have regretted it.
And so then you finally say, I'm sure someone solved this problem. Let me find the library. Sure enough, there's a library. It's called Beautiful Soup. It actually parses XML stuff, which HTML is a subset of XML. And so you use Beautiful Soup. You scroll down as quickly as possible and find the example. Oh, look, there's an example of how to parse HTML. Perfect. So you paste that into your code. I like to have it in the top order. Okay. Cool. So let's do, we just have HTML. Sorry. So what we're saying is run this class. Here's the string of my HTML and what parser to run the HTML parser. Okay, let's get rid of this nonsense of having to sort through the HTML ourselves. Let's use someone who actually knows what they're doing. Print soup. Let's see, I don't know what that gives me. Okay, interesting. So printed out the string, but now let's notice how it's all nicely formatted. It's got, new lines and stuff like that. That's kind of nice. But that doesn't really help us right here. You can do prettify. That's good to know. Okay, you can get the title of stuff. It just so happens I found this nice handy example that is exactly what I needed. What this does, it says, hey, in this soup, find all the A tags and iterate over them. So from that, and not just the A tags, actually specifically, it's the A tags, and then from there you get the href from it. Okay, so that makes sense. So find all the A tags, find all, so that's going to return a list potentially, because it's finding all of them, and probably more than one, maybe not, because it could be 0. It's going to set that to link, and it's going to run. The link is going to say, well, I have this A tag, but I don't really care about the A tag. I care about the href part of the A tag. So let's get the href. Okay, like this. Save it, and then print it. Okay. Oh, now we're seeing some interesting stuff here. Now we're getting, So this first page right here has all these links in it. That makes intuitive sense. I would probably, if I were doing this, I would probably first start with a page I controlled HTML for, so that I could kind of see, yeah, I added these 2 hrefs and it found them. But we don't have time for that. Okay. Notice how there's 2 different types of links, though, right? Kind of different formula here. You got all these ones where are /bootcamp, and got some other ones that are like HTTPS. This is kind of equivalent to on like your terminal, a relative link versus an absolute link. These HTTPS ones are absolute links. Saying, this is the website for it. This one's all relative to wherever you're currently at, or the page, the root of the page. I don't want to make trouble because I mean, if we searched every link and went to all those links and went to all those, we would trace the whole internet potentially, right? So let's limit the scope a little bit. Let's not go to any page beyond. Let's only go to relative links, only things that are contained on this on that website. So I don't want to go to merce.byu.edu because that'll take me to byu.edu and that'll take me to all their articles that are linked to all these other things, and it would explode very large. So let's just limit it to this. Okay, so how do we limit it? So let's see, so this href equals that. Oh, no, what just happened? So what should we do? How should we look at this? There's probably a better way of doing this, but let's just say like if href 0, if the first character is equal to that, then let's print the href. So we're essentially filtering out all non-things that don't start with that, or that start, yeah, we're filtering out those. We only want those ones that are relative. Does that make sense? So we should, we should not see this one, we should not see this, if we do this right. Do you agree?
Yes.
Okay. Cool. Awesome. Now we're okay. So okay. So what should we do now? We've gone to a page, we found all the links. Now we want to go to those pages, right? So what we really need to have is actually, so we essentially want to add it to this list right here of URLs. Say, okay, well now go to that, right? Okay, so there's some issues here though. So I could say, okay, well, yeah, it fulfills what I need to do. So I'll just do URLs.
Only an issue if you don't want to go forever.
But, yeah, you're right. I can append. So I take a list and I append to it. I say, okay, hey, I'll go visit this new URL. Well, that's not going to quite work because it's not a complete website, right? If I do this in requests, it won't work. So really what I should do is probably something like this. If I could do like this, maybe like root URL. Let's kind of break this up a little bit more. Let's do this. And then maybe instead, okay, we'll do like full URL is equal to root URL plus URL. We'll just go to this full URL. So now let's make sure everything in our URLs thing is relative. Okay, cool. I think that will work, but there's an issue before I run it. Anyone notice anything? I'm going to append to this URLs list. I'm also iterating over this list.
I won't recheck it.
I'll recheck it. I actually don't know what to do. It probably actually worked fine because it's Python, but it makes me feel kind of not quite right, saying I am changing I'm changing the size of my thing that I'm iterating over. And I don't like that. That's simply not a good idea.
I always regret it when I do that.
I always regret it. So you want to be careful of that. You don't want to iterate over. So let's kind of change how we do this. Let's maybe, and also once we check this over, we don't really need it in our list anymore. Like we kind of just like get rid of it. So maybe like a queue would be better. We're all familiar with queues, right? 235. Python, queues, lists, they're all the same, right? It's just what functions you call them. So let's do this instead. While the length of URLs is greater than 0, while we have things in our array, and that's another weird thing about Python is this is often what you call on a list. There's not .length on a list. It's a function that you pass in the list. I don't know why that's not the case. Okay, new URL, urls.pop. Pop things off. Okay, I'm not going to do this here. Let's make sure we haven't messed anything up. Okay, looks like it's about the same output as I expected. Okay, cool. So now this makes more sense because now I'm not iterating over this thing. I can change it. It's going to be changing all the time, the size. So it's going to pop it off. This is now gone. See you later. And then I'll go in here and I'll append new things onto it if there's anything new to append. Does that make sense? Well, do we all agree with this? Just for debugging, let's like print URLs at the end of all this, and let's like exit out of here. Like we don't want this to run forever because I don't know quite yet. I haven't thought through yet what will happen when it goes back up here after we append a bunch of stuff. But let's see that things are in this URL list. Okay, good. Lots of things are in there. Awesome. Okay. Oh, wait a second. Huh. This thing is in here, but we've already been to that page. So yeah, sure enough, the link we just went to has a reference to itself. That's gonna not be good, right? Because if we'll just stuck in a loop forever, we'll just keep going to the same page over again. So what we really want is, let's say, URLs like to visit. Let me change that. URLs to visit, and then we probably want like visited URLs. We probably keep track of lists. URLs we've already visited, so we know not to visit them again. See the...
Use the spell checker too.
Yeah, I do. So it detected it, that even though it's a variable and it's got underscores, it knew that I spelled visited wrong. It underlined it. It's an unknown word, so it's really handy, yeah. Okay. So with this in mind, we need to do some things. We say, okay, well, first of all, we don't want to add it to our list of visit if it's already been visited. So if href is in the visited list, sorry, not in. So there's another Python thing. So in is an operator. We say, hey, here's a string, here's a list of strings. Is this string in this list? It's exactly how you'd say it in English. Is it in it or is it not in it? If it's not in it, then add it. Now, maybe it's because it's Python. I get a little sensitive to this white space kind of stuff. And I don't like cascading if statements all the way down. So you have to like scroll to the right or have it wrapped. So we could just like simplify this, right? And say, well, it has to have that and this. Right? That's the same equivalent. Do you agree with that? Okay. So it has to be a slash in the front and it can't have been in our visited list. If it's been in our visited list, then that means we visited, we already got the URLs. Okay.
That's way nicer than C, I just want to say. You don't have to do some fine with iterators and check that it's not equal to end. And
now I will say, there's no free lunch though. Though it looks really simple conceptually, it's not like they somehow magically found a way to search your list in super fast. Like it's still having to iterate over it or doing some magic stuff that you'd have to do in C yourself. So I remember thinking like, is it doing anything special? No, it's probably just iterating over that list and trying to find it. So if this had a billion things in it, it would take a while to run this piece of code. It might be doing something faster in the hood, but okay. We're missing one more thing. Oh no, let's run it. Let's see what happens. And let's get rid of this. Let's go for it. Okay, one more thing. Anything web related, gotta be a little careful. Let's slow it down. Let's add like a second delay, just so we don't like start visiting the whole world and gets brought back to my computer and you'll get mad at me. So let's sleep for time. So I'll just say, hey, like sleep for 1 second and then run this through. So we can kind of start, but well, we don't have any debugging stuff. So even if we did that, we wouldn't see. So let's fix that. Let's see here. Let's do print. You probably should use a logger, but we won't do that. Visiting full. Okay, this is another handy feature of Python, relatively new, is the F strings. There's lots of ways to do this in Python. This way I like, essentially says, if you put anything in curly braces and you have this F in front of it, then whatever in here, I'll look up that variable name in your local environment. So I'm printing out this variable right here. Okay. You run it? Okay. That seems about right. Oh. I'm visiting SQL all over, constantly. Okay, we did something wrong. What do we do wrong? Oh yeah, we haven't added the visit list. Okay, nice. I like that. Yeah, I don't know if there's any other way of putting it. Yes, that's not what we did. Okay, visiting list. And let's do like right at the beginning, append. Let's see, we just want the URL, not the full URL, just the URL. Okay, so as soon as we, I don't know, maybe we should do it down here because we haven't really visited quite yet. Now we visited at that point. I don't know, wherever we want. Okay. So that will help. Okay, let's try it again. Okay. Got through that. Okay. What happened here? We went to a .pdf. PDF is not Unicode encoded. It's not UTF-8. It's PDF. So we probably should add a try around here. If in doubt, try. Accept, and we'll just copy this error. So if that happens, if there's if that fails, then we don't want it anyways. Like it's not probably HTML. There's probably better checks. But let's just, if it's not HTML, then let's just ignore it. So we'll just do continue. And we're all familiar with what continue does, right? In this case, I still want to visit it. So let's move that back up here. So what that's saying is, if it fails, then jump back up to the top and keep going.
Did you visited the PDF? I guess so.
I visited enough to know I don't want it. Okay. I don't know. Is it working? Oh. What's happening here? It's saying, I don't know, do people think, is this intuitive? I feel like earlier on, I remember like not feeling very intuitive, the Python exceptions. Now I kind of know how to understand them, but it's giving you a line that was an error and telling you what the error was. Index error on this line right here. So we're only indexing in one place, this place right here. So that's the problem. But let's kind of figure that out. What's going on here? We don't have time. I would probably print out the href, say, what caused this href to fail? So I can understand why that's good. But in this case, it's pretty easy. It's an empty href, nothing in it. So I'm indexing into a list, a string that has nothing in it. Okay. So we should say, well, if the length of href, we need to the length of href.
Say if href, right?
Yes. Okay. Well, that's a good point. Why would we want to do that? If href. So I prefer this because to me it conveys more meaning. But that is an option. You could use if href because an empty string is considered a false value. But yeah,
same thing up on your while loop. I was going to complain. So
that I probably would have. I didn't think of that. Right. Okay. I know we're late on time, so let me just run this one more time. Let's see if this works.
You should go scrape the whole internet. Make sure you do it from your BYU computer so that everybody yells at us.
I mean, that second is pretty slow. Like, I don't know,
Yeah, you probably can't get in trouble for that.
Should we take away the sleep? Take away the sleep. I'm bored of this. Still not that fast because it is happening linearly, right? I'm waiting for that request to happen. If I really want to do this, I paralyze it, say, hey, all these things, go off and get them and bring them back to me.
Yeah, I mean, you're visiting all those web pages on GitHub, right? So
GitHub knows I'm.
It's cost Microsoft a whole nickel. So
I can afford it, right? Wait a second. Is anything? Is this working?
You're making jokes about getting in trouble. At what point would you actually like get in trouble for doing something like this?
I don't know. It's a public website, so it's a little hard to tell because I don't know. Maybe our repository is really popular and just tons of people are going to it.
Well, I guess get in trouble from who? From Microsoft. They're really smart. I'm sure they have people hammering their stuff all the time. If you ask for too much stuff, they'll probably just cut you off and they won't care, right? But I don't know. Maybe BYU networking would, if you did enough network traffic that BYU networking noticed, then maybe.
Yeah, that's fair. You're down like terabytes data. This doesn't seem right. This is taking a long time. I think I've seen
repeating. Yeah, it's repeating web URLs.
What's that?
It's repeating URLs.
Yes, it is.
Oh, yeah, you're right.
What's wrong? There's one thing we missed.
Stuck in the directory for tutorial. Right?
Yeah, I think so. But why is it stuck in the directory? Did we think of all of our possible issues here? If it's been visited, its length, what are we missing here?
Oh, if the list of URLs you haven't visited is empty.
Oh, empty. Full. What if it's already in the list of URLs? We don't check for that. We need to check for that. So we essentially need the same thing here. And it's not in the, what did I call it? I don't remember. URL to visit. It can't be in either of those things. We have never been able to, essentially what we're saying is we haven't seen this ever before. We haven't visited, we're not going to visit, then append it. So we were appending it, even it might have been in the list somewhere down the line, we would still add it to our list. Now, you notice the fancy thing that just happened here? On save, I run black, the formatter, which everyone should use. Use a formatter, use black, it's called black, Python formatter, black. I think it's kind of clever.
The uncompromising code.
Well, so why I like it is it's clever because it comes from Henry Ford saying you can have any, for the Model T, you can have any color you want as long as it's black, is what the quote is from. And I think that's somewhere in here. Any color you like, you can write your code any way you want as long as it's formatted exactly like this is kind of what it's saying. It's uncompromising. It's kind of, it's very strict on how you do it. I like that. Oh, let me tell you, I used to love to handcraft my Python so beautifully just to exude who I am as a person. And then someone would go mess it up, or I'd forget who I was. And a year later, be like, what was going on? Let me format it a different way. I'm a different person now. And I spent so many hours handcrafting it perfectly. What's the point? It's just code. It's not meant for that. Just use a code formatter so that you don't have to worry about those things and just make your life easier. So learn from my mistakes. Don't handcraft your code. Just use the formatter. It works well enough. Sometimes it does things I don't like, but Okay, with that, let's see, it should end relatively quickly, I think, here. And I think we have everything. Done. Well, that was not that useful. It didn't do anything. I'll leave that to you to.
How many we visited?
Oh, look at this list. Okay. Okay, fine. Sure enough. We can do print. Let's finish visited. And let's do list of visit URLs. But okay, yeah, let's do that.
You can even do function calls in there.
Do whatever you want. That's awesome. I spelled visit wrong. Thank you. Okay, and then let's see those links for URL in visit URLs. I'm going to sort it. I'm going to sort it. I want to see alphabetical. Print. Just sort. Yep. URL. Let's do like
you enjoy
my
Python
favorite
more?
part of 235.
It's just a function call. I don't know. Let's see
I
that.
like it better if you multiplied that.
Oh yeah.
Touche. Okay. I actually, times 80. Let's do 80. Okay. I mean, we're printing them out right there, so I don't know, it's not giving me anything new information. But it'll be sorted. How many did we visit? We visited 60 links, and these are all the ones we visited. Beautiful. I did think, what could you do with this information? Not much. I mean, you can just know that's there. But let me show you one thing real quick that I thought was kind of cool. Import collections. Python has some great libraries to it. There you go. Python collections. You know what really bothers me is nowadays, I don't know if it's my thing. I feel like there's all these, I have a hard time finding the Python documentation. There's all these tutorials on how to do it, but there's this thing called counter. Anyways, it will count how many occurrences you have of anything, which is really handy sometimes. So let's create a counter right here. And let's do like words counter. Oh, sorry. Let's do it this way. Just give you some from collections import counter. Different way to import. Import specific things and importing that specific thing. Okay.
Import counter as count.
The words. Let's look at let's go to word tree. We don't have time to do that, unfortunately, but let's do that. I'll cut to the chase because I don't. Okay, well, let's do it.
Yeah, 15 minutes.
We have 15 minutes?
Yeah.
Sure. You're having fun, right?
So much fun.
Update. So what we really want to do, let's take a step back. Let's print out this soup. Let's examine it a little bit more. That's what we want to look at. And we don't actually want to do the stuff yet. Okay, that's what it looks like. That's not very intuitive. Let's do like a dot. It's one string. Let's do the split and get all the words. I don't know. That's not a really great way to find words because there's hyphenated words. But let's essentially, we're going to split everything based on a white space. So if there's a white space between you, you're going to be split now. So let's do this. Sorry, change word count. Count. Okay, and let's just call this words. And I'll do word count dot update is called words. Just so we make sure we do this right, let's do print word count and then let's exit. And type is not callable. What do I do here? Okay. Oh, does this not work?
That suggests that soup is not, doesn't it? Why would soup be?
Dang it. How do I do this stuff? Contents. Not gonna just guess. This is an attribute. Okay. Oh yeah. Let's not deal with the soup. Yeah. Let's deal with just the HTML. Sorry, that's what I meant. HTML. Okay. So that's one big we downloaded from the internet. Soup does some interesting things. Apparently, we can't split on it. It's not straight. Okay, let's do that. Okay. So what it's showing here, you can't see, it's a dictionary. It's got a key and the value, how many occurrences it had. That's not super intuitive. It's got a lot of gibberish in here and HTML stuff. So let's see if we can strip out the HTML. So how do you strip out HTML? You ask Google. Full soup, strip HTML X. strip HTML tags from a string. That looks close enough. Is this what we want? No, that's not what I want. Okay, I can go into this page. I found this is okay. This is it. No, this is the one I want. It doesn't actually do that great of a job, but I've done it. So let's print that out. So instead of using words, let's just print, see what this gives us. Okay, it's a generator. We don't have time to go into those, but I have to convert to a list to print it out. Okay, that looks less HTML-y. Let's go with that. Oh, that's what I need to do. How do I do this? What's the right way? Okay, let's do for string in chunks of strings, but we want to do a string.split. We want to split. It's like here, Unmer Computing Bootcamp is what it gave us, but we want to split that into little words. So we want to split on this, and then we want to do word count.update. Okay. All this stuff. Let's print this more time to see it's kind of doing what we want it to do, and then let's run it. Okay, that looks about right. I mean, they've got some weird things in here, like there's no space between the period. There's a new line examples, but let's ignore that. You know, we can refine this a little bit. Here we got a get, we got code, we got include. These all look like reasonable words. And okay, got that guy. I don't know what that's in there. Okay, let's run it. And let's print out as we go. Let's do a competition here. See, print word count. We'll see who kind of more time becomes the leader. Oh, this is not okay. No. Let's look back at our documentation. See, oh, look, it's the most common. Okay, we don't want to print the whole counter. We don't want to do most common. Let's do top 5, and let's not print this visiting anymore. Let's just trust that's working. We want to see. You can see all the occurrences. The is most okay. 2. Oh, this is boring. But it found out. So now you go to the word cloud of these things, occurrences.
You do a word cloud.
I have no idea. I mean, there's
There'll be a Python package to make a word cloud.
I started with this last time. Gravity. No, come on. XKCD, Python. Do some good comics. And
You like type it in the terminal and pulls it out.
yeah. Import anti-gravity. You know, it's always a module. How are you flying? Python. I learned it last night. Everything's so simple. Print hello world is just print hello world. That's Python 2. Don't use that. I don't know. Dynamic typing, white space. That's all what you're probably thinking. Come on, come join us. Programming is fun again. It's a whole new world up here. But how are you flying? I just typed import anti-gravity. That's it. I also sampled everything in the medicine cabinet for comparison. I think it's the Python. Just Python's that easy. It's importing anything and it just works. It's beautiful. So find word cloud, Python, library or module, I don't know. And I'm sure word cloud. Well, there you go. Give it something and import it and run it and it'll give us a cool word cloud. I'm not going to do that right now. But that's the type of thing is you could do something or maybe like, you could, so there's the machinery to actually get the web crawler work, but this is where the fun stuff happens. Like actually, what do you want to do with this information? Do you want to scrape it for email addresses and spam all those email addresses that you found online? I don't know, whatever you want to do with it, word counts, I don't know, the world is your oyster. Any questions on that? Okay, Python's awesome. Python's easy. Learn it. You'll be a better programmer, better researcher, better human being.